Welcome to this explainer. All right, today we are zeroing in on a very specific, absolutely crucial block of your study guide, NCP-MCI 7.5, Objective 15.3, Analyzing VM Performance, specifically using the analysis dashboard. If you're gearing up for this exam, you already know that performance troubleshooting is way more than just memorizing what buttons to click. It's about fundamentally understanding exactly how Nutanix surfaces data and knowing the specific boundaries of Prism Central, which we usually just call PC. Today, we're putting a massive magnifying glass on analyzing virtual machine performance. We're going to be working off the baseline for AOS 7.5, AHV 11.0, and PC 7.5. Grasping this particular subtopic, it's not just a box to check for your certification, it is literally what keeps mission-critical infrastructure running smoothly in the real world. So let's get into it. Here is our game plan for this session. First, why VM performance matters. Second, a walkthrough of the analysis dashboard. Third, common exam traps and edge cases. And fourth, the key facts you need to memorize. Starting right off with Section 1, why VM performance matters. Okay, to set our baseline, let's quickly define our core acronym, a virtual machine or VM. Now I want you to really focus on a metric called CPU ready time. In the system, you'll see it displayed as hypervisor.cpu_ready_time ppm. This is super important because this metric is absolutely not a measure of how hard your VM is working. Not at all. It's actually a measure of how long your VM is forced to just sit on the bench. It tracks the percentage of time a VM is perfectly ready to process a thread, but it's stuck waiting for the hypervisor scheduler to actually grant it access to a physical processor. This usually happens because of CPU over-provisioning, or maybe you have some noisy neighbors on the cluster. When you assign way too many virtual CPUs across the cluster compared to the physical cores you actually have available, the hypervisor scheduler just struggles to find contiguous physical cycles, so your VMs are literally forced to wait in line. So what is the why behind this metric? Why do we care so much? Well, high CPU ready time isn't just an ugly red line on a back-end chart. It actively destroys application throughput in real-world scenarios. Think about a high transaction SQL Server database. When that guest VM gets placed in this waiting state by the hypervisor, all database operations simply halt. And here's the really tricky part. At the application layer, the software has absolutely no idea that the hypervisor just paused it. It thinks time is passing normally. So this leads to a cascading nightmare of compounding delays, dropped packets, and massive application timeout errors for your end users. Catching these invisible underlying bottlenecks, that is exactly why you need total mastery of the analysis dashboard. Moving right along to Section 2, our analysis dashboard walkthrough. To kick off any kind of dynamic monitoring, you first have to know your navigation path cold. You open the application switcher in Prism Central, select Intelligent Operations, and then navigate over to Analysis. Once you're in, you'll notice a timeline right across the top. This is great because it lets you set your monitoring period. You can look at a tight 3-hour window or stretch it all the way out to a full month. Establishing that timeline early is absolutely critical for gathering accurate baseline data before you even attempt to isolate anomalies. But honestly, the true star of the show here is that big plus Add Chart button right in the center of the screen. That is your launchpad for building any custom performance view in the dashboard. Clicking that Add Chart button introduces us to a fundamental architectural rule of this dashboard. You absolutely need to internalize these two concrete examples for the exam. Option 1 is a metric chart. Think of this as scaling horizontally. You choose one single metric, say CPU usage, and you map it across many different entities, like 5 different VMs, so you can compare them side by side. It's like casting a really wide net to find a single problem across your cluster. Option 2 is an entity chart. This one scales vertically. You are zeroing in on one specific entity, like maybe that single critical database VM we talked about earlier. But you're tracking many metrics at once: CPU, memory, disk IOPS. You do this to get a comprehensive, holistic view of that one machine's health. All right, I'm going to slow down right here because this is a huge gotcha for the exam. You cannot mix these two approaches, ever. The dashboard enforces a very strict limitation. You cannot define a single chart to monitor multiple metrics for multiple entities at the same time. You literally have to pick a lane. You either compare one metric across a group or analyze a group of metrics for just one single machine. Why? Well, this strict boundary ensures the Prism Central database doesn't get utterly overloaded with exponential queries. Plus, it keeps your visual data actually readable. Just imagine trying to render 20 different metrics for 20 different VMs on a single line graph. It would just be a wall of useless tangled noise. So when you're actually building a custom chart in PC, you're going to follow these 4 exact steps. First, you click Add. Second, you choose your chart type. Third, you select your targets, following that strict rule we just discussed, of course. But step 4. Step 4 is the subtle one that exam writers absolutely love to test you on. When you're dealing with time series data, you have to define the aggregation parameter. If you don't explicitly define it, Prism automatically defaults to calculating the average for that metric. Now, why is that an exam trap? Well, relying on the average aggregation can completely mask short, really intense performance spikes. If you are hunting for microburst bottlenecks, imagine a CPU spiking to 100% for just 5 seconds every minute. An average taken over an entire hour is going to hide that completely. As an admin, you have to actively choose maximum from that dropdown if you're hunting for those microbursts. Let's transition into section 3, exam traps and edge cases. I need you to pay very close attention to the number 50. This is not just some arbitrary limit, it is a hard threshold that is heavily documented in the PC.7.5 release notes. To optimize display performance, the analysis dashboard is only going to render the first 50 VMs on a chart. Think about it. If you tried to load 500 VMs on a single time series graph, pulling thousands of data points simultaneously, your web browser would probably just lock up and crash. So, to prevent that, Prism Central implements this hard stop at exactly 50. And this brings us right to a classic exam edge case. Picture this. Your boss asks for a performance CSV file covering 100 VMs. You jump in, you build a metric chart in the analysis dashboard, you see the chart render on your screen, and you think, great, and click the Export CSV option directly on that chart widget. What happens? It fails to give you all your data. Because of that rendering limit we just talked about, exporting directly from the chart limits your CSV to only those first 50 entities. If an exam scenario asks you how to bypass this 50 VM rendering limit for a massive data export, the correct workaround is that you have to navigate away from the analysis section entirely. You must use the reports dashboard to generate a full, unclipped data export. Let's do a quick knowledge check right now with a mock scenario based on the rules we just broke down. Think carefully about those chart limitations. Here is the question. Can you graph both CPU usage and memory usage for a group of 10 VMs on a single analysis chart? I'll give you a second to think it over. The answer is a definitive hard no. Remember our golden rule from earlier? You must pick a lane. Horizontal scaling for one metric or vertical scaling for one entity. This scenario is asking for multiple metrics, CPU and memory, across multiple entities, 10 VMs. The analysis dashboard strictly prohibits this to protect the database integrity and to keep the chart readable. To actually solve this in the real world, you'd need to either create a single metric chart displaying just CPU usage for all 10 VMs, or build an entity chart for one specific VM showing its CPU and memory usage side by side. All right, bringing it home with section 4, key facts to memorize. Here are the 4 foundational facts you absolutely need to lock in for this objective. First up, licensing. Creating your own user-defined analysis sessions requires a valid Nutanix Cloud Management, or NCM license. Second, data retention. Prism Central keeps alerts and events for 90 days, and it stores hourly performance data for 1 year by default. Third, our chart rules. Never forget the difference between a metric chart and an entity chart. And remember, you cannot ever mix them. And fourth, the limits. Always keep that 50 VM render limit in mind and the fact that you absolutely have to use reports for a complete massive data export. To wrap up this explainer, I really want to leave you with this final thought. Knowing all these dashboard features for an exam is fantastic, but taking this knowledge and applying it to find real-world application bottlenecks, that is where you truly become a master infrastructure administrator. So I have to ask, how will you configure your very first custom analysis session in your own lab to hunt down VMs suffering from high CPU ready time? Go get into Prism Central, build a metric chart, remember to change that aggregation to maximum so you don't miss those microbursts, and go find out what is waiting in line. Keep studying, stay curious, and you are going to absolutely crush this certification.